We have talked about angle pair relationships before. In this section we are going to look at a few theorems, and even though it's evident that all right angles are congruent, there is a theorem which we can prove saying that all right angles are congruent. So over here, if you look at angles 1 and 2, by virtue of the fact that they're both right angles, we can conclude angle 1 is congruent to angle 2, and that would go in the statement section, and in the reason section we would say all right angles are congruent. The next theorem says if two angles are supplementary to the same angle, then they're congruent to each other. So let's say over here you have angle 1 and angle 2 are supplementary, and angle 3 and angle 2 are supplementary, then we can conclude that angle 1 is congruent to angle 3, and our reason would be if two angles are supplementary to the same angle, then they're congruent to each other. Similarly, if you have two angles that are complementary to the same angle, so we have angle 1 and angle 2 are complementary, and angle 3 and angle 2 are complementary, we can conclude that angle 1 is congruent to angle 3. Some theorems have names and some don't, so I just prefer not to use the names. Just remember the words. You don't have to remember them word for word, but as long as you get the gist of it. If you have two intersecting lines, form two pairs of vertical angles. So just let's look at the diagram on the right hand side. Angle 1 and angle 3 are vertical angles, so I'm going to write that on the side here. Vertical angles, angle 1 and angle 3, and they're congruent, and angles 2 and angle 4 are also vertical angles, and they are congruent. In this sketch, there are four linear pairs, and the linear pairs are angle 1, angle 4, angle 1, angle 2, angle 3, angle 4, and angle 3, angle 2. So these are our four linear pairs. And the linear pair postulate states that if two angles form a linear pair, then they are supplementary. Note that in this particular postulate, it doesn't say that they add up to 180. It just says they're supplementary. But you know that the definition of supplementary is that the angle measures 180 degrees. So if you were using this in a proof, you would actually have two steps. The second step would say measure of angle A plus measure of angle B equals 180. Definition of supplementary. We have already stated over here that vertical angles are congruent, and the theorem is vertical angles are congruent. Let's just work the following examples. You are given two intersecting lines in each case. Let's number these problem 1 and problem 2. In each case, you need to find the measures of the angles. So the first thing we're going to do is find the values of x and y. So we kind of go on a little hunt here, and we look to see what equations we can set up. Well, 16y seems so easy to me. So I'm looking at angle that measures 16y. Then I look at the angle across from it. Oh, I'm in luck. That also has a y. Then I ask myself, well, what is the relationship between these two angles? Are they vertical angles or are they a linear pair? They are not adjacent to each other. They fit the definition of vertical angle. So you write your equation. 16y equals 18y minus 18, degrees and degrees, and the degrees cancel out. So you get 16y equals 18y minus 18, and that gives us negative 2y equals negative 18. Therefore x is equal to 9. Similarly, we could set up oh, I didn't mean x is equal to 9, did I? I meant y is equal to 9. So let me just fix that. Y equals 9. So I could also solve for x in the same way, and I would say 6x plus 2 degrees equals 10x minus 2 degrees, and you get, if the degrees will cancel out, distribute the 6, and now we get minus 4x equals minus 14. Okay, divide both sides by negative 4 and negative 4, and you get x is equal to 7 over 2, and x equals 3.5. So some of you may feel very uncomfortable that you have x as a mixed number. That's a-okay. Now all you have to do is you have to go back and you have to plug x and y into the variables. I'm going to leave that for you to do and find the values of x and y. Now let's look at the example on the right, number 2. In number 2, I'm going to see where the angle pairs are which contain the same variable. The advantage of that is when they have the same variable, then you could just come up with one equation. So I'm going on my little hunt here, and I see that there's a 10y here, and I see that adjacent to that is an angle with a y in it, and these two angles fit the definition of a linear pair. I know that if two angles form a linear pair, they're supplementary, which means that they add up to 180. So this time, instead of using vertical angles, I'm using the linear pair postulate, which says these two angles are supplementary, they add to 180, and that gives me 13y equals 189. Ooh, I need to fix that. That should be 169. So y is equal to 13. I have two ways to go from here. I could actually set up another equation with x, or what I could do is I can substitute for y in here, and that gives me 3y plus 11, 39 plus 11. So this angle measure is 50. And the angle across from it is 4x minus 22. So now I can say 4x minus 22 equals 50. 4x equals 72, and x is equal to 18. And I will leave it to find the angle measure. What if you were to set up another equation with just x in it, using the fact that these two angles, this angle here and this angle here, form a linear pair? Then I would just say 4x minus 22 plus 7x plus 4 equals 180. That's a linear pair. So hopefully I will come to x equals 18 again. So I'm going to work this out. That gives us 11x minus 18, and I'm combining like terms. When you work on the same side with variables and numbers, you combine like terms. When you work on both sides of the equal sign, then you will use one of the properties of equality. Add 18 to both sides, so I get 11x equals 198. Divide by 11 and I get 18. Oh, I am in luck here. My two answers match, which means that I have worked x out correctly. Once again, go ahead and plug x and y in both cases into the expressions for the angles and find the actual angle measures.